Hi, Robert. Robert, while we're waiting for people to join, do you have any questions right now? Excuse me. Sorry.
No, I don't have any questions.
Okay, so what I want to do then right now is actually go over the drawing that you did for your Rube Goldberg, and then that way I can give you feedback right now, and hopefully that will help you out a little bit for your final draft, okay? Because I don't know if anybody else is going to join. I'll give them a few minutes, but I think that's probably the best way to help you out for right now, okay?
All right.
All right, so I just gotta find it. Oh, good. Okay. I can actually understand yours. All right, so I'm going to try to figure out what's going to happen first, and then I'm going to go over all the labels and see how it goes. So it looks like you're probably starting up here. You're going to roll a ball down a ramp. It's going to hit dominoes. They're going to knock over each other, hit another ball that is going to roll into a can. All right, this is where I'm a little lost now. So the can is gonna, okay, the can's gonna fall over. So what is the can gonna be resting on for it to fall over? Or is it, this is all flat? This is all flat. This is like an aerial view, right, Robert?
Yeah.
Okay. So the can knocks over, the chips are then gonna spill out onto a plate
A
or a bowl.
plate.
Okay. All right, good. So I like that. One thing is there is not really a simple machine in here. So going downhill is not a incline plane. That's the closest thing to an incline plane that you have. So
Yeah.
let me try to think of how we could. What if you start with like a pulley, or I'm trying to think. A lever wouldn't work. What if you built, so I like that you have the aerial view. What if you built a pulley here? So you just have kind of like a dowel on like clay or something that goes straight up, and then it's attached to the pulley. So you have the two cups, and the at the ball is resting on the very edge of your ramp. So when you pull the one side down, the other pulley goes up and it hits the ball, and that's what knocks everything in motion. And then you'd have your simple machine in there. All right, so increase. Hi, Morella. So I'm just going to go over your individual drawings to help you guys out, okay? Unless you have any specific questions.
Okay.
All right, so we're just saying, so this is Robert's picture. It looks great. He's just missing the simple machine, so we're talking about possibly adding a pulley to the beginning. So when you push down on one side or drop a marble in on one side, the other side goes up, knocks the ball into motion, and we can get some chips at the end. So I just want to go over all of the labels right now. So we have an increase in speed, it's going downhill, yes. A decrease in speed, so as it's rolling, it's slowing down because it's probably a heavy ball and this is on a flat surface, so that would work. A change in velocity, let's see. All right, I don't see a label with a change in velocity, but right here, Robert, would be a good change in velocity because it's turning. So remember, anytime a change in velocity is either a change in speed or a change in direction. So here's changing direction, so that would work for that. Greatest potential energy would be at the very top where the ball is resting on your ramp. The greatest kinetic energy should be at the very end because it's transferring from potential to kinetic energy. For yours though, the greatest kinetic energy may actually be at the very bottom of your ramp because this is all flat surface. So this would be where your greatest kinetic energy would be. Change in momentum. Momentum is mass and acceleration. So a change in momentum would be right where the marble hits the dominoes because you're changing the mass. You're going from the mass of the marble to the mass of the dominoes. The greatest force would be right here where it hits the dominoes because it's also the greatest kinetic energy. An increase in potential energy. Where do you have it labeled? Okay, so when you build that pulley system, that's actually where your increase in potential energy is going to be. So when the one side goes down, the other side comes up, and because it's lifting up from the ground or from the middle up to the top of the ramp, it would be increasing potential energy because we're adding height to it. Anywhere at all would be an example of friction. So remember, we have 4 frictions. We have rolling, static, fluid, and sliding friction. So wherever you label your friction, you just need to be able to explain why. So here it looks like you're labeling the ball as friction. So as it rolls, that would be rolling friction. So you just explain that in your rubric. And then if you add that pulley to the beginning of it, that's where your simple machine would be. So really, you don't even need to adjust really any of your drawing except for that very beginning where you'd add a pulley. And I think it looks great. Do you have any questions, Robert?
No, I'm good.
You're one of the few that doesn't need to do a lot at all. That's good.
Nice.
All right, so if you want to log off, you have your feedback. I'll also post this video for you guys, or maybe I'll just email this video for you guys because it's really specific to the 2 of you. All right?
All right.
All right, good luck. Let me know if you have any questions later. All right, and Morella. I'm going to open yours. So did you work with Maria on this?
Yeah.
Okay. Do you call her Maria or Isadora? Sorry.
I don't know. I call her whichever.
Okay. All right. So what were you going to say?
It kind of took us just like 2 hours to draw a simple thing.
Really? Okay.
We're really bad artists.
It's a little dark, so I'm going to try to make it bigger so I can see it.
If you want, I can send you another picture of it.
I think this is okay for right now. I can see. All right, so we have your labels and your objects, the different colors. All right. Oh, so you're doing this outside.
Yeah.
Fun. All right, so you're gonna have your swing set. The rope. What is that say there? A cup of paint.
Yeah, so we're kind of gonna do like the painting version.
Okay, so you're going backwards. I'm going this way. So you're starting here, and then you're gonna have the paint on the swing set, and it's gonna go down on the canvas. Okay, cool. Are you guys gonna actually build this and try it?
Yeah. So we're doing this at my godmother's house, and she has a swing set, so we get to like build it and do all of it.
All right, good. So one of the things we learned with the that one video, so when you're doing it, you might want to get rid of, this is just a random rope. This isn't the actual swing, right?
Yeah.
Okay. So if you watch the video really carefully, what we had to do is we put a cup. I don't have any cups, but I have my. All right, so pretend this is a paper cup or a plastic cup. We had to put a hole in the bottom of it and then cover it. And it took a while for us to figure it out exactly, but then we covered with our finger, pour the paint on top. So on the top of the cup, the strings were attached. You need to have it like up. You need to have like a platform right here that you don't mind getting paint on. So like a plastic table or a chair or something, so that when this comes down, it's gonna knock into the cup and then let the cup freely swing. Does that make sense?
Yeah.
Okay. So the hole has to be there first. You pour the paint in, and you can actually make it really cool if you do like a couple of different color paints. So you kind of like layer it. If you've ever seen an acrylic pour, that's how they do it. So then as it goes, you're gonna get like a rainbow of colors, and it makes that cool like swirly thing.
Oh yeah, we could do that.
Yeah, it would look cool. And you can even there was another thing too. So we had to water down some of the paint. So it's all gonna depend on the paint that you use because we were using like a house the wall paint. It was a little bit thicker. If you use like one of those washable kid paints, it's like a water-based like washable paint, that's already really liquidy. So how big you make the hole, that it took us a while to figure that one out. I worked with that group a lot.
Okay.
Depending on the size of the hole that you make and the thickness of the paint. So those are the two like variables that you're gonna have to play with for a while. So it's a little frustrating because it takes a little while to get it, but once you get it, it's like I just think it comes out so cool. So
Yeah.
all right, so you're gonna start with looks like a marble here on a top.
Yeah. So we do it tomorrow.
All right, so it's gonna like drop, go back and forth.
Yeah.
Roll down, and then this is your screw. Is that a screw there? So this won't count as a simple machine because it's going downhill instead of up. But
Oh, okay.
we can maybe try to figure something out. But you do want it to go down to have enough force to hit the paint. And since you're at home, you can probably use like a baseball or softball, like something a little bit bigger with a little bit more mass. It'll give it a little more force. Because we really
Yeah, that's what we were thinking of doing. So the like marble would go its course, and then it would like hit the big ball, and then it would like.
okay, good. Trying to think if I wonder if you could even trying to think if you could do like a lever at the end or well no, because it really needs to be on a flat surface. So yeah, I would definitely have like a baseball or something heavier hit the can at the end. So you'll have this set up. So that's pretty good. I'm just trying to see. Okay, so you have the change in velocity. So if you do make this some kind of a screw, maybe you want to bring this screw up to the top because you want to have a lot of momentum down here.
Oh, okay.
Maybe you could even start like build a little freestand pulley, kind of like what I was telling Robert to do. So if you get like a dowel or some kind of like pole. So I happen to have my empty paper towel thing here. So if you have something like this where you have you can attach like a like loop or something where you have the strings coming on either side. And then you pull one string, and this is how you could start it. You pull down one string and the other string comes up and then hit a lever or something at the top. So if you do that, and then you have a lever here that has the marble on it at the one end, just barely balancing. So when the pulley comes up, it hits the lever, knocks the marble out, and then it kind of goes through this whole series. And then you can get rid of this screw here because you'd have the pulley and the lever. So you have two simple machines already. And then when maybe at the very edge here is where your baseball would be. So the marble goes down, the marble hits the baseball. Hopefully it has enough force by then to move the baseball. You might need to just make this last one like a little bit more of an incline to have a little bit more force. But if you get the baseball at the very edge, so it's just barely balancing, really any force should knock it down. That'll come down on a little bit of a, whatever this is, where your table's gonna be set up, that's gonna have your paint, and then knock the paint and then let the rope swing. So I think that would be good. So let me just go over your labels to make sure that your labels are good. So we have A is, okay, so we have an increase in speed. So yeah, any of these slopes will be an increase in speed, so that would be fine. A decrease in speed, when it hits, when the marble hits, I don't know where you labeled your decrease in speed.
We put it with like the screw.
Okay, so actually when your marble hits the side, you just have to explain that in your rubric. Once it hits, it's gonna stop, and then it's gonna roll down because of gravity. So that would be your decrease in speed. So any one of these areas where the marble is going to hit the side and then bounce back and forth, that'll be your decrease in speed. Change in velocity. C is here. Okay, so same thing. Anywhere it's going to hit and bounce back and forth. So if you get rid of that screw, because that's going to take a little bit more to build. If you get rid of that screw, this will change your velocity. So that's fine. When you're building this, it's just kind of like come to mind. They had that styrofoam, but they also had it on a like a flat angle. If you have this straight up and down, then you could build kind of like a, so you don't want to have it flat. You want to just kind of build it like this or something like this, where
Yeah, that's what we were like thinking of doing.
I would even use a toilet paper roll, and you can cut them in half so you can use it for two. So it looks like this, so then it rolls down, but it won't come out either side. You can guide it a little bit.
Yeah, that's what we're thinking of doing, and because we're like collecting paper towel rolls. I have like 3.
Okay.
Collecting some, so.
Good. Toilet paper, paper towel rolls, either of those work. You could also even take like, your cereal box, and it's already formed for you because it's in a box shape. I don't have anything around me right now, but just kind of cut the edge off, and then it's already guided for you also. So it would be like a box shape.
Yeah.
A little bit big, but that would work also. So if you have some cereal boxes, you have 4 more corners, 4 more edges that you can work with. All right, so that was, so we're on C, change in velocity. All right, greatest potential energy should be at the top. I think you have that as a D up there. So that would be your greatest potential energy. So again, if you make that pulley system and you have a little marble resting up here, well, you do the pulley system and the lever. So the pulley comes up, hits the lever, which will knock it down. So the lever will be, I would put the lever on the trifold. And if you watch a couple of those other videos, a couple of kids did something like that. You just have to figure out how to fix the lever to the trifold, and you could use a nail. If you put a nail through even like part of the cereal box, and then like hot glue the back of it so that it still pivots, but just the hot glue doesn't allow the nail to come out, that should work. Or even a screw. If you have a screw that has like a bolt at the ends of it, so it's still loose and can pivot. All right, greatest kinetic energy would be right before the softball, baseball, whatever you have hits the paint can. I think you have that. You have it here. So pretty much the same thing. The greatest kinetic energy would be at the bottom of the first swing, really. Momentum, change in momentum is here. Okay, good. So you have a bunch of places you're changing momentum. So going from the marble to the softball or baseball, because that's a change in size, that would be a change in momentum. It's starting to slow down as it goes, so that would be a change in momentum. So momentum is mass and acceleration. So where you have it is fine, or you can label it any other place too. Okay, the greatest force would have to be right where you're gonna hit the paint can.
Yeah.
Not paint can, the cup of paint. Increasing potential energy. All right, so when you have that pulley system, your initial would be to pull down one side where the other side goes up, and because the other side is going up to hit that lever, that would be your increase of potential energy. I'm not sure where you have it here. Here you have it going downhill instead of uphill, so it would have to be going up. So your potential energy would be somewhere over here. Remember, potential energy has to do with height. So it has to be going up to increase the potential energy. Friction, really anywhere is friction. You have those 4 types of friction: rolling, static, fluid, sliding. You could even put a little twist on yours because you have a hole in the paint can and the paint is flowing out. You can use that as your fluid friction. Or the marble or the ball rolling would be rolling friction. Static friction is where it's staying still. So if you wanted to label the marble at the top of the lever before it gets hit by the pulley, that would be static friction. So you have lots of frictions that you can label. And then you would have 2 simple machines, so that would be extra credit. And then you're helping Maria out is you're going to be like way above 100% for this marking period, which hopefully you're going to enjoy building and it won't be like too much of work. I appreciate you helping her out a lot. I know
Yeah, it's no problem really. I really enjoy science, so it's not that like
good.
boring.
I'm glad, and hopefully, I know she probably hasn't really been doing anything at all, so hopefully you can, just that communication is helping.
Yeah.
All right, good. So do you have any questions?
No, but like, could you email me like the video so then I can make like the changes and everything?
Yeah, I'll email this to you, and I think when you're building it, you'll start seeing where you need to make like the changes. So it's going to take a little bit longer to build it, but because you're going to build it, sorry, I wouldn't even revise the blueprint yet. Just keep in mind that you're going to be adding the pulley and the lever. So the pulley will be kind of freestanding. The lever you're going to want to put on your trifold, and you want to add a table here so that it has some kind of flat surface to keep the paint can on so the paint stays inside the can because it has a hole in it. So build it first, and then if you want, instead of drawing it, you can even take a picture of it, like as it's set up before you let it go, and then you could just label your physics concepts on that, so you don't have to redraw it.
Okay.
All right. So if you have any questions, let me know. I'll share this video with you. It takes a little while to like convert it or whatever it does. So hopefully it recorded it and it'll work. I'll email you and Robert the video. Okay.
Okay. Thank
All right.
you.
Good luck. Let me know if you have questions when you're building.
All right. Bye.
Bye.